Good evening. So sorry for being late because very hard to find the parking and access to here. Okay. So today basically we are talking about how 3D scanning actually using in BIM application. I think BIM is currently something still new in construction industry, but actually is something that are going fast and then moving fast now. So one of the approaches actually to collect all the information in the BIM application is the 3D laser scanning technology. So today basically we're going to share with you what is a 3D scanning technology and how normally people using scanning and then apply the scanning data to the BIM application. So any question, basically you can just raise your hand and ask them. Okay? Okay, so this is the agenda I'm going to go through today. So basically, we are share a little bit with you on our scanner solution. Okay, I make it fast, but actually I'll share more on the information that actually how we are using scanning technology to apply into BIM application. Okay, so beside that, we also will share with you what 3D laser scanner can use also. Okay, so actually there are so many applications now for 3D laser scanner, and then last and actually some activity we're doing in Malaysia. Okay, so this is just some of our company background. Okay, so we are from Bandwork. Basically, we are the distribution of one of the 3D laser scanner brand called Faro in Malaysia. Okay, so this all I won't go through much.
Vero, the world's most trusted source for 3D measurement technology, develops revolutionary portable measurement and imaging solutions. Vero's commitment extends well beyond product performance and constant innovation in order to build an ongoing relationship with our customers and help make their products' processes the best in the world. The Vero Laser Scanner Focus 3D is a high-speed, three-dimensional laser scanner for the detailed measurement and documentation of large objects, spaces, and buildings. With a range of up to 120 meters, the Focus 3D creates photorealistic, three-dimensional images of reality. Thanks to its intuitive control concept with a touchscreen display, it's as easy to operate as a digital camera. The rotating laser of the scanner touches, in the truest sense of the word, its surroundings. The laser beam is used to measure the distance to the object and, together with the device's rotation angle data, determines the coordinates in space. Several million of these 3D coordinates result in a complete three-dimensional impression of its surroundings. Color scans are produced with the help of the integrated digital camera. The scan data is saved on the internal SD card, making it very user-friendly to transfer the data to a computer. Vero's Scene software automatically combines individual scans with the aid of integrated sensors in the Focus 3D, such as dual-axis compensator, height sensor, and compass, to create a cohesive point cloud. Data acquisition by means of 3D laser scanning is faster and more reliable than conventional documentation methods. Whether for three-dimensional building documentation, monument preservation, or forensic crime scene documentation, thanks to its simple operation and compact design, the Laser Scanner Focus 3D is ideally suited for a variety of applications. At Vero, our focus is on simplifying our customers' work with tools like the laser scanner that empower them to obtain data more quickly, easily, and with less cost than ever before. Today, thousands of customers worldwide trust and work successfully with various Vero solutions, making Vero the world's most trusted source for 3D measurement technology. The Vero Laser Scanner Focus 3D, the world's smallest, lightest, and most affordable 3D laser scanning solution.
Okay, so just now basically just share a short video with you about what is a 3D laser scanner. So what is a 3D laser scanner been related to BIM? Okay, so first of all, of course, we know BIM basically is a digitization of all kind of construction data into construction industry. So of course, some of you might not know actually what kind of a method we use in the construction site to collect the data in the construction site. So there are many tools actually we can use. Okay, if you have been approached some of the conventional method, some people might still using some tape. Okay, some even more advanced, they use some distance meter. Okay, just shoot, they give you a measurement. Okay, some actually they are surveyors, so they can use some total station or we call light. Okay, to get more measurement inside the site. But as we know that the design of structure of the construction is always so complicated. So in order to get an efficient way actually to collect all kind of data, basically we need something to even can measure the point much more faster. Okay, so of course we know all the method just now we mentioned before, each time you can take one measurement. Okay, you can imagine just a very small room, how many times you need to take to get a measurement. So in a tall building, how many times you need to get hold the data over there. So scanner basically is a more advanced and more efficiency approach. So how fast a scanner can approach or can measure this all point? Basically, it can reach close to 1 million points per second. Okay, so basically what we see just now is all the 3D model, but basically we are collected using 3D scanner. Because each scan we are doing over here, basically we can get millions of points. So from the million of points that we collected, basically we can put all the information inside the BIM application, or we can use the data to create the 3D model. Okay, so when the data do all the integration part, actually we have all the sufficient data to fit in our BIM model. Okay. Okay, so just show you a little bit actually how 3D laser scanner works. So after this presentation, basically I will use our scanner to basically just scan this room one round, so you can see actually how fast you can get every single detail inside the room with just a very single basic scanning. Okay. So as you can see actually how a 3D laser scanner works. Basically the laser are emitted from the side of the scanner and then shoot on the center mirror side. Okay, so of course normally we can't actually see the laser beam because it's actually spinning very fast. Normally we just see the center mechanism part is spinning very fast. Okay, but the accuracy or efficiency they can achieve is really impressive, which close to 1 million points per second. Okay. Okay, so this is how it works. So for a room or for a factory area that as large as this, basically we just need to do few scans. Basically we can gather all the information over there. So comparing to conventional method, as we need to see all the drawing in the 2D, which normally some of the engineers can understand. But 3D laser scanner, after you scan, basically we will get everything in a 3D type. So we can get the precise X, Y, and also the Z value. Okay. So of course, there is also an evolution of a 3D laser scanner. Basically, 5 years back, a laser scanner looked like really huge. Okay, the size is about 20 kg. So basically, at that time, 3D laser scanner is not so popular because the technology has not yet matured. Okay, so come to nowadays, basically, 3D scanner has been designed to a very small size, actually just 5 kg, and then it's close to like an A4 paper size. Okay, so basically even male or female engineer they can easily using the equipment to get the measurement on the site without knowing much knowledge on survey. Okay. So during the scanning time, basically we also will do some camera. Okay, so actually we're taking the photo together. So once we done the scanning, basically we can use the photo to colorize back our result. Okay, so what we see on the scanning result is basically colorized. Okay, so this one will show you actually how our 3D laser scanner workflow. Basically, you will find out that even this technology is very high technology, very fast, but that designed actually in a very user-friendly and simple way. Okay, so we can see this video to give you a better understanding the workflow, how normally we do a scanning until the processing part. Basically, this scanner is designed a little bit like a digital camera. So actually, you just mount your thing, press the scan button, that's all. After scan, basically we can import all the data to software to do the processing. So of course you see the data over here is not only for one scan. You may compress of 50 or 100 scans. So normally for a large building, you do easily 100 overscan to get a detailed information of everything. Okay, so basically just now is a process how normally we do from scanning until the point cloud. Okay, so some actually they just need all the point information, so actually they're just done until this step. So some basically they need all the point cloud to convert into 3D model. So basically we have another software actually using to feed from the point cloud to the 3D model. Okay, so basically how it works as what you see is actually quite simple, but it actually what you get is almost similar to what a surveyor can done on the construction site. Okay. Okay, so next I show you a little bit on how we do it from point cloud convert into a 3D model. Okay. You can see all the floor plan and all the 3D model inside the Revit basically a draw based on the point cloud scanning. So actually it's not a design stage, but actually they are drawing using what we are measured on the site. So actually the color is basically we overlay the previous and the current scanning data. When we overlay by the color, they are telling you what is the difference between the tolerance. Okay, so in color, for example, like red color is basically telling you it's out of the tolerance. Okay. It's for a lot of oil and gas industry, how we're going to draw the piping based on what we scan. This is for building, and you can see how we fit the wall using the 3D scanning result. So this basically gives you some idea how we are doing the full flow from scanning to processing the point cloud and even until the 3D modeling. Basically, once we have drawn all the 3D modeling, we can just put in your BIM platform and actually all the information we can extract from there. Okay. So besides actually from that, actually we still got a lot of features actually will help a lot during the BIM process. For example, we can create all the permeability map actually to show you that what is the difference between the progress during the construction stage. So easily just overlay between each process of the scanning, basically we can know that what kind of a tolerance is out from time to time. Okay. So actually we can also create the cross-section also profile using the software. And then also we can doing the 3D model comparison for SBuild. Okay, so this is actually quite common using even in overseas country because from time to time after the construction stage, you actually need to QC and checking what kind of status of the building. So basically we can use the scanner, scan all the things, and then convert into 3D model, and then we can overlay back what we have been designed. So actually, just overlay like this, using the color basically will tell you what kind of a tolerance been up. Okay. So we can create the auto image and doing the 4D analysis and etc. Okay, next we just share an example to you. Okay, so basically this is one of the customers that are using 3D scanner to do QC on their construction site. So you can see this is one of the construction site. They are still in the development stage. Okay, so compared to normal conventional way, you need to use some tools actually to do this more checking, but not much information actually we can extract. Or actually we need to consume a lot of time to check even just a very small part because the conventional tools is very slow. Okay, so by using scanner, basically just do some scanning for this small part. Basically we can get all the information on this level. So by using the information that we are scanning, just like what we've been show you earlier on, basically we can use it, processing, and then create a 3D model. Okay, so just as simple as that. After we have a 3D model, basically we can, using the software, to overlay back what we have been designed. So basically, just overlay with the previous design model. Actually, it tells you by color what is the part that been out actually by the tolerance that you're setting. Okay, so easy to check. I think most of the case in Malaysia before that all are checking using a vision. Okay, so I would think a lot of things are missing, and then a lot of things basically you can't check even properly. Okay, so what is the advantages actually using BIM? Of course, one part is we can do a lot of QC. Okay, another part also, if everything we have been set properly inside the BIM, basically we can just duplicate to build up another building within the fingertips because we have all the information we have precisely. Okay, so that's why BIM now is so much important in construction market now. So of course there are so many tools we can use basically to get the information, but of course 3D laser scanner will be one of the best to use. Okay. So with that actually we can do a lot of analysis by comparing the previous design and also what is doing during the construction stage. So this is a lot of report that we can generate using the software. So a lot of diagram and also color of comparison basically will show you after you overlay both the model. Okay, so that is basically one of the case that we're using the 3D scanner for construction industry. So, but actually nowadays, 3D laser scanner has been used in a lot of applications. So actually we just briefly share with you what 3D laser scanner is being used besides of construction industry. So this is some of the case sharing overseas. Actually, this one is also another construction application which they actually use the scanner to scan all of their construction stage to get the S-build. Basically, nowadays another common application of scanner is also to create back the S-build drawing, because a lot of construction in Malaysia, actually their S-build is not up to date or even missing. So what is the approaches or the method that can be regenerate or actually survey or actually measure in the fastest way? Of course, there will be laser scanner. Okay, so basically in China, basically they use a scanner to scan all the things. As you can see, they are just from scan to the point cloud, and lastly creating the model, and then they can use it actually to send it to other way to duplicate things. So actually, 3D scanner also quite commonly used on tunneling. Okay, what is the reason that we use scanner in tunneling? Because in tunnel we don't have any light. Okay, so conventional method, basically you still need a light to see where you want to survey. But for scanner, they don't need. They can get every single point inside the tunnel, and then mostly when we survey on the tunnel, basically we just want to know, to monitor whether the tunnel have some deformation or not. So we actually just progressively scan the tunnel and then put the tunnel model from time to time to compare. Then we know whether the shape is in changes or not. Okay. So we have also 3D scanner using for civil construction, which used for slope monitoring. We have the scanner used in Singapore for shipbuilding.